Assalamu alaikum students. In this recording, you are going to learn about module 4. As you all know, yesterday I have shared the module 3 recording. So now the module 4 will be recorded and it will be shared to you all now. Okay. So now without further delay, let us start our session. So in this module, we are going to learn the content related to the concepts of access control and the database security. So here, first, let us see what is access control. What is access control? Because see, so far we have learned about protecting the data using encryption and authentication. But however, there is another question that may rise: who is allowed to access the information of the system? So this is where the access control comes into the picture. So access control is the process of deciding who can access a resource and what are they allowed to do and when they are allowed to do it. So in simple way, I can say that access control will ensure that the only authorized user can access specific resources while preventing unauthorized accesses. So when you think of this as like a security guard for a computer system, as a security guard will check whether someone is allowed to enter the building or not. In the same way, the access control system will check whether a user or the device has the permission to access the data, application, or the physical locations. So the National Institute of Standards and Technology, NIST, they defined the access control as the process of granting or denying specific request to obtain and to use the information and related information processing services. So then it will help you to request the enter specific physical facility, which means according to the definition by NIST, access control applied to both the digital and physical security. So the digital access, which means like when you are logged into your university portal or when you are accessing a company's database or when you are trying to open a patient records in a hospital or when you are using online banking service likewise. Whereas coming to the physical access means like entering the server room or accessing a research laboratory or entering a bank wallet and using employee ID card to enter the office building, like many things. So in overall, if you see, access control is one of the foundational pillar of the cybersecurity. So encryption will protect the data from being read by unauthorized individuals, while the access controls will determine who is allowed to access the data in the first place. So the modern organizations they implement the access control through well-defined security policies, authentication mechanisms, authorization rules, and auditing systems. So by ensuring that only authorized users, the applications and devices can access the protected resources and they can access control which help to maintain the core security objectives of confidentiality, integrity, and the accountability. So, by granting the permission only to authorized users, programs, and the systems, the organizations will protect the sensitive information, it can prevent unauthorized activities, and it can maintain the confidentiality, integrity, and accountability of their critical assets. So then let us see about the access control principles, the access control principles. Then we will see about policies, requirements in detail. So now we understand what is access control is all about, right? So let us explore like how it works with other security functions. Imagine when you are entering a secure bank wallet, okay? So several security steps will happen before you allowed inside. Like first they will check your identity, then the bank will verify your identity, then the system will check whether you have the permission or not. If it is approved, then access will be granted. So your activity is recorded in a log. So this entire sequence of represents the relationship between the access control and other security functions. So the effective access control, which always depend on the coordinated operation of identification, authentication, authorization, enforcement, and mainly auditing. So, together, all these the security functions will ensure that only the legitimate users will gain the appropriate access to protect the resources while maintaining the accountability through the continuous monitoring and logging. Then the access control policies. So now the thing is that how does a system decide whether a grant or denial of access? So the correct answer is going to lie in the access control policies, because an access control policy will define the rules that determine who is allowed to access specific resources under certain conditions. Then different organizations, um, they use different policies depending on their security requirements. So first, what is an access control policy? See, an access control policy is a set of rules that determine who can access a resource and what action they are permitted to do. And when you think of it like the rule book that the system follows before granting the access. And then we have mandatory access control. So MAC, which stands for mandatory access control. Unlike the DAC, here the user cannot decide who receives access. Instead, the system will enforce the strict security rules. And then we have the role-based access control, RBAC. So the role-based access control is like, instead of assigning permissions to the individual user, the permissions are going to be assigned to the roles. So the users will receive the permissions by being assigned to those roles. And then lastly, we have attribute based access control. So the attribute based access control will stand for attribute based access uh, control, which is the most flexible access control policy. So instead of considering only identity or the role, the system evaluates multiple attributes before granting the access. So remember, the access control policies, they are going to determine how the authorization decisions are made. The DAC will given resource owners control over the permission, and the MAC will enforce centrally managed security labels, and the RBAC will grant the access based on organizational roles, and ABAC, which is going to make the dynamic decision using user resources and environmental attributes. So an access control system is effective only if it follows a set of important security principles which known as access control requirements. So the access control requirements are going to be the essential features and principles that ensure an access control system is secure, reliable, and properly managed. So these requirements will help the organizations to protect their systems while allowing authorized users to perform their work efficiently. So before granting the access, the system must verify the user's identity. So without reliable um, authentication, the access control decisions cannot be trusted. So why the authentication is important? So imagine like a university portal. If someone simply enters a username, so the system cannot assume they are the real owner. So the authentication verifies the identity using passwords, fingerprints, face recognition, smart cards, one-time passwords, multi-factor authentication, many things. So if you see the requirement, reliable authentication is going to verify the user identity before the granting of access. Then fine-grained access is like controlling the access at detailed level, and the coarse-grained access like control access to large resources. Then least privilege is like grant only the minimum permissions necessary. Then separation of duty is like handling the purpose of divide critical task among multiple individuals. Then administrative policy is like defining who manage the access control rules and all these things. So an effective access control system is going to build on reliable authentication, appropriate authorization, granularity, the principle of least privilege, separation of duties, secure default access policies, and a well-defined administrative controls. So now let us see the access control security requirements SP 800-171. So many government agencies and organizations, they use these requirements to protect the controlled unclassified information. The NIST special publication, which is called SP 800-171, it is going to provide the security requirements for protecting the controlled unclassified information stored, processed, and transmitted by the organizations. So it is widely used by the government agencies, defense contractors, healthcare organizations, then research institutions, even the companies who are handling the sensitive government information and all. So the CUI, which stands for Controlled Unclassified Information. Controlled Unclassified Information. So this information that is not classified as secret or top secret, but still it requires the protection. But it requires the protection, like the employee records, student information, or the fee payments, or medical records, or research data, exam results data. So although the CUI is not classified, the unauthorized disclosure could still cause the harm. So when we are handling that, we need to make sure that all these requirements and their purposes are successfully implemented, and the NIST SP 800-171 clearly demonstrates that effective access control will extend beyond authentication and authorization. So by enforcing the least privilege, separating critical duties, securing remote and wireless access, protecting mobile devices, managing the user sessions, and safeguarding the controlled unclassified information, the organizations can implement a layered defense that significantly strengthen their overall cybersecurity posture. So then we are going to see now the elements of access control, the various elements that are involved in the access control. So here there is no matter whether you are using Windows operating system or Linux operating system or Android operating system or any cloud services or any banking system. So the access control is always based on the three elements. One is subject, second one is object, third one is access right. So when you think of them like answering three simple questions: who is requesting the access, that is the subject; what is being accessed, that is the object; what action is allowed, that is the access right. So the first element is the subject, where it is an entity that requests access to a system resource, that is the object. And then many operating system organize the subjects into three common classes like owner, group, and the world. Okay, so after that we have the object. So the second element is the object, where an object is a system resource whose access is controlled. So the objects are the resources that subject want to access, like files, directories, databases, records, then programs, then printer, network resources, many things. Then the third element is access right. So an access right specifies the action that a subject is allowed to perform and an object. In other words, it is going to define what operations are permitted. So in overall, if you see, every access control decision is based on the three fundamental elements: the subject who requests the access, the object, the resource being protected, and the access right, where the permitted operation. Together, these elements enable the systems to enforce the security policies, ensuring that only authorized subjects should perform authorized action on protected resources. Now, let us see more in detail about the discriminatory access control, DAC. So an access matrix is a table that is used to represent the permissions that subjects have on different objects, as you can see in the slide also. So it is going to answer three important questions. What is that? Who is requesting the access? Which resource is being accessed? What operation is allowed? So when you think of it like a permission table, so the access matrix has two dimensions: rows, which will represent the subject, columns, which will represent the object. So each cell will contain the permissions, that is the access rights that a subject has a particular object. So then we have like row based decomposition. So it is going to store one row at a time, and each subject store the object it can access, and it is called an access control list for the subject. So then we have the column based decomposition, where it is going to store one column at a time. So each object is going to store the users which is allowed to access it. So this is called an access control list. So remember, the access matrix is going to provide a conceptual, a conceptual framework for discriminatory access control by defining which subjects can perform which actions on which object. Because the real world systems contain large numbers of users and resources, the practical implementations rely on access control list and the capability list to store the permissions efficiently while enforcing the secure access decisions. So now the important question may rise here, whether the computer actually stored a huge access matrix or not. No, not efficiently, because a real organization may have thousands of users, millions of files, databases, applications, printers, network resources. So when you have a complete access matrix that would contain millions or even billions of entries, most of which would be empty. So an access control structure is what? A data structure that is used to effectively store and manage the permissions represented by an access matrix. So instead of storing every empty cell, the system will store only the permissions that actually exist. So that is why, remember, the access control structures are efficient implementations of the access matrix. So instead of storing a large and mostly empty matrix, the systems will use the access control list, capability list, and the lock key mechanism to manage the permissions effectively, and these structures will enable fast, scalable, and secure authorization decisions in the modern operating systems, databases, and even in the cloud environments and all. So as you can see here, a sample table, the alternate authorization table. So this is how it happens. So a table that store only the permissions that have the actually been granted between the subject and object. So instead of storing a complete matrix with many empty cells, the authorization table will record only the valid access permissions. So when you think of it as a permission register, like the access matrix will have the subject, access code, and the object. So each row of the table will contain the three pieces of information: what? Subject, object, and access, right? So by recording only the existing permissions, it reduces the storage requirements while it provides the same authorization information used to enforce the secure access control in the modern information systems and all. And then it can have an extended access control matrix. See, the traditional access matrix mainly focus on protecting the files and other simple resources, but in a modern operating system, the security must also control the access to run the processes and to handle the hardware device, to handle the memory, and even other users or the subjects also. So to handle that, memory is another important resource. So the modern operating systems, they prevent unauthorized programs from reading or modifying another program's memory. So in overall, the extended access control matrix will expand the traditional access control model by treating the processes, devices, memory regions, and the subjects as it is protected with the objects alongside it is going to file and uh, clear the database. So this comprehensive approach will enable the modern operating system and cloud platform to enforce consistent security policies across all the critical system resources, providing strong protection against unauthorized access and the malicious activities and all. Then we have the access control function. Access control function. So here the access control function is the mechanism that check every access request and decide whether to grant or deny the access based on the organization's security policy. So when you think of it like the security guard who is standing at the entrance of your company to protect the resources. So every request must pass through this security guard before the access is granted. See, no user can directly access a protected resource. Every request must first examined by the access controller, and the controller will check who is requesting the access, which object is being accessed, what operation is requested, is this requested permission is listed or not, and then not every user can change the permission. Only the authorized user may add permission, remove permission, or modify the permission. So in other words, the access matrix is also treated as a protected resource. Only the authorized user can modify it. See, the access matrix controller is responsible for managing the permissions which is stored in the access matrix, that will be adding new permissions, removing permissions, updating existing permissions also. So in overall, the access control function will ensure that every request to access a protected resource is evaluated before the access is granted. So by relying on the access control to enforce the permission and an access matrix controller to manage the authorization rules, so the organizations can securely control both the resource access and the permission administration. So reducing the risk of unauthorized access and the privilege escalation is also very important. So this is how the various set of rules that are governed by the modification to the access matrix, like it is like what I can say, the commands. and the authorization and the operation also. So here if you see, the access control system commands are like some set of rules that are going to define the access matrix that can be modified securely. And these commands will ensure that only authorized user can grant the permission, remove the permission, create the permission, or create the user, delete the user, create the object, or deleting of object. So these are all like the administrative operations that are used to maintain the access matrix. So please remember the access control system commands, they are going to define the secure procedures for modifying an access matrix. So by controlling how the permissions are transferred, granted, revoked, and how subjects and objects are created or removed, these commands will ensure that the authorization policies remain accurate, consistent, and protected from unauthorized changes. So then the protection domains, which is more useful, like Unix, Unix is there, Unix file concepts, access controls, many things are there. So the protection domains are going to provide a more flexible and practical way of controlling the access than simply assigning the permissions directly to the users. So a protection domain is a collection of objects together with the access rights that a process is allowed to use on those objects. So a protection domain defines what resources can these processes will access and what operations can it perform. See, instead of assigning the permissions one by one, we can place all the permissions into a single package, and that package is called the protection domain. So if you see, the protection domains are the fundamental concepts in operating system security because they define the execution of environment for a process rather than simply the permissions of a user. So by assigning the processes only the permissions they require, the operating systems will implement the principle of least privilege, reducing the attack surface and implementing the consequences of software vulnerabilities. So the distinction between the user mode and kernel mode further strengthen the system security by ensuring that only trusted operating system components can perform the privileged operations and the access protected memory. So the Unix file system is the way the Unix and Linux operating systems are working, like storing the files, organizing the directories, keep file informations, managing the permissions, and locating the data on the disk for various operations. So the Unix file system will separate the file names, metadata, and file content, making it highly efficient and scalable. So the directories maintain mapping between the file name and inode numbers, while the inodes uh, will store the metadata that required to manage the access, ownership, permissions, and storage locations. And this design will enable the features such as like the hard links, efficient file lookup, and the robust permissions management. And it remains the foundation of modern Unix-like operating systems, including Linux, Mac operating system, Android operating system, and all. So then the file access control mechanism, the file access control mechanism. See, whenever a user try to access a file, the Unix will check three things. Okay. who is the user, that is the UID, user ID, and which group does the user belong to, that is the group ID, and what permission does the file will allow. Only if these checks are satisfied, that is going to be having a access that will be granted. So the Unix file access control, where the user ID. So every Unix user has a unique number that is called user ID. So the UID uniquely identifies a user in the operating system. Okay. So why the user numbers instead of names? Internally, the operating system works with numeric IDs because they are faster and more efficient than storing the user names. So the Unix file access control, which is based on a simple but yet highly effective model that combine the user ID, group ID, and the permission bit that is stored in each file inode. So the standard owner group others permission model will provide efficient day-to-day access control, while the special permission like set UID, set GID, and the sticky bit, they enable the controlled privilege elevation, collaborative group management, and the secure shared directories. So this model has remained a cornerstone of Unix and Linux security for decades due to its balance of simplicity, flexibility, and the effectiveness. So then the file access control. The file access control. See, normally a program will run with the permissions of the user who start it. Okay, like set user ID. So this means a program which run using the owner's privilege instead of only the user privilege. Like for example, in Linux operating system, every user can change their own password. So the password information is stored in protected system files such as like /etc/shadow. So the normal user cannot directly modify this file, but however, the password program has the set UID bit that can set. So where a user runs bash past WD, the program temporarily execute with the permissions of its owner, typically root, allowing it to update the protected password for file security. So in overall, if you see the Unix special permissions extend the standard owner group others permission model to support the secure system administration and collaboration. So the set UID and set GID will provide the controlled privilege elevation, enabling the trusted programs to perform a specific administrative task without granting the users unrestricted privileges. So the sticky bit protects the shared directories from accidental or malicious file deletion, while the root account will retain the full administrative authority to manage the operating system. So together, these mechanisms will balance the usability, flexibility, and the security in the Unix-based systems and all. And then we have the access control list. Access control list. After this, we are going to see about the role-based access. So here in the access control list, ACLs, if you see, it is going to extend the traditional Unix um, permission model by supporting fine-grained authorization for the individual users and even for the groups also. So instead of relying only on the owner group other structure, the ACLs will, the access control list will allow the organizations to assign precise permissions to specify the users and groups while maintaining the existing ownership model. And this makes the ACLs particularly valuable in collaborative environments, enterprise file servers, and the modern Linux systems where flexible but yet secure access control is essential. Now, let us start with a new concept, that is role-based access control. Role-based access control. So, in a role-based access control, the users will receive the permissions by assigning one or more roles. So, without the RBAC, the permissions are assigned directly to the users. So, every user permission must be managed individually. So, here the role-based access control will grant the permissions based on an organization role rather than an individual identity. So by assigning the permissions to the roles and the roles to the users, the RBAC will simplify the administration, support the principle of least privilege, and provide a scalable, consistent, and secure access control solution for modern organizations like universities, hospitals, banks, and cloud computing environments, all these things and all. Then the general RBAC variations. So here, a family of RBAC with four models we have: the role-based access controls, so which consists of four models, and each model build upon the previous one by adding the new capabilities. Like the RBAC 0 is the basic RBAC model, then RBAC 1 is like the combination of RBAC 0 plus the role hierarchy, that is the inheritance. Let me show you the diagram. Yes, then RBAC2, which is like RBAC0 plus the constraints, that means the restrictions, and the RBAC3, which is the combination of RBAC0 plus role hierarchy plus constraints. So in the first one, the RBAC0, it defines the essential building blocks of RBAC. Without RBAC0, the other model cannot exist. And then RBAC1, that is the role hierarchy, that is the inheritance. So here it is going to extend the RBAC0 by adding the role hierarchies, and it is also called the role inheritance. And then RBAC2, which is handling with the constraints. So here the RBAC2 extend the RBAC0 by adding the constraints, I mean restrictions, where the constraints will define the rules about how the roles may be assigned or activated. So the RBAC family will evolve from the basic RBAC 0 model to the comprehensive RBAC 3 model by progressively introducing the role hierarchies and security constraints. Together, the users, roles, permissions, and sessions from the foundation of role-based access control, while the inheritance and constraints will provide the flexibility and security that required by the modern enterprise information systems and all. So then let us understand what the constraints is all about. What is the constraints is all about? So the constraints, it is like a rule, or you can say the restriction that limit how the roles are assigned or used within an RBAC system. So when you think of the constraints as like the organizational policies that prevent the mistakes, fraud, and conflict of interest, without constraints, the user could receive inappropriate combination of roles or excessive privileges. So that means the RBAC constraints will strengthen the access control by restricting the how roles are assigned and activated through mutually exclusive roles, the cardinality limits, and the prerequisite role requirements. The organizations will enforce the business policies, support separation of duties, and reduce the risk of fraud and unauthorized privilege escalations, so that it will make the RBAC mechanism as a secure and practical access control model for modern enterprises and all. See, with this, let me stop the session. So the remaining slides I will give you as like another recording soon. Okay, thank you all.